Welcome to solverfy.
Question 60 is a weak base strong acid titration with two separate calculations of two separate weak bases. You are asked to calculate the equivalence point volume for the titration of each weak base with the strong acid HCl, and after knowing the equivalence point volume in milliliters, calculate the pH of the equivalence point volume. For the first one, we'll calculate the equivalence point volume by starting with the volume of the weak base ammonia, 65.5 milliliters or 0.0655 liters. If we multiply that by the molarity of the ammonia concentration, 0.234 molar, we will get moles of ammonia. We recognize that for acid-base titration reactions, the molarity or the stoichiometry is 1 to 1. So 1 mole of ammonia requires 1 mole HCl. Once we have the moles HCl, we can then divide by the molarity of HCl in order to get the volume of HCl required to neutralize this volume of 0.234 molar ammonia. But it wants it in milliliters, so we will multiply by 1,000, and we get 122.6 milliliters of HCl is required to neutralize 65.5 milliliters of 0.234 molar ammonia. Now that we know the equivalence point volume, we can calculate the equivalence point pH. As with all pH calculations, pH is equal to the negative log of the hydronium concentration. How will we get the hydronium concentration? Well, at the equivalence point, the ammonia, NH3, has all been converted into its conjugate base ammonium, NH4+. So every mole of ammonia that we started with has now become a mole of ammonium. To solve for the pH of a solution that contains ammonium, we need to take the square root of the Ka value multiplied by the concentration of ammonium. Square root of the Ka value, the Ka value being Kb divided into Kw. Kb for ammonia is 1.8 times 10 to the negative 5. We divide that into Kw, and this gives us the Ka value. So, a hydronium concentration is the square root of Ka for ammonium multiplied by the concentration of ammonium. How will we get the concentration of ammonium? Well, because all of the ammonia has become ammonium, then every mole of ammonia is now a mole ammonium. So if we calculate the moles of ammonia we started with at 0.0655 liters multiplied by the concentration of ammonia and divide that by the new volume, this will be the moles of now the formed ammonium divided by the new volume will give us the concentration of ammonium. The new volume is the 65.5 milliliters we started with, plus the 122.6 milliliters we added. So, the square root of Ka multiplied by the concentration of ammonium will give us the hydronium concentration. We take the negative log of that, and we get pH, 5.17. For the second part of this problem, the second titration, we have methylamine, which is also a weak base, 21.8 milliliters of it at 1.11 molar. So if we take the 21.8 milliliters, convert it to liters, 0.0218, we can then multiply by the concentration of the solution to get the moles of methylamine. We then recognize the stoichiometry is 1 to 1. 1 mole of methylamine will react with 1 mole of HCl. Then when we have moles HCl, we can divide by the molarity of HCl to get the liters of HCl required to neutralize 21.8 milliliters of 1.11 molar methylamine. But it wants it in milliliters, so we'll multiply by 1,000. and we'll get an equivalence point volume of 193.6 milliliters HCl. pH, as always, is equal to the negative log of the hydronium concentration. How will we get the hydronium concentration? Well, all of the methylamine has been converted into its weak conjugate acid, the methylate. So what we need to do is calculate the concentration and the Ka value for the conjugate base to methylamine. Then, if we multiply those two values together and take the square root, that will give us the hydronium concentration. So the Ka value will be equal to Kb of methylamine divided into Kw. We can look up the Kb value of methylamine, and it's about 4.47 times 10 to the negative 4. Divide that into Kw, we now have Kb. Kb multiplied by the concentration, this is Kb, multiplied into Kw, we have Ka. Ka multiplied by the concentration of the now formed weak acid. How will we get the concentration of the formed weak acid? Well, every mole of methylamine we start with is now a mole of its conjugate acid. So we'll solve for the moles of methylamine we start with by taking the volume times molarity. This is the moles of methylamine we started with, and now the moles of the conjugate acid we just formed. We divide by the new volume, the 21.8 milliliters plus the 193.6 milliliters, and this will be the concentration of the weak acid. Multiplied by the Ka for the weak acid, and then we take the square root, we get the hydronium concentration. We take the negative log then of the hydronium concentration, and we get the pH, which is 5.80.